Let's talk about SWR, standing wave ratio, or VSWR, voltage standing wave ratio. SWR is the ratio between the transmitted and reflective waves. Now, ham operators know that an SWR1 is perfect, a 1.5 is excellent, a 2 is okay. Anything above 3, then you have to correct for the mismatch between the transmitter and your antenna. Now, where do these numbers come from? Let's take a look at reflection coefficient. This symbol here is the capital gamma, and all it is the square root of the reflected power. So if your reflected power is 4%, your reflection coefficient is going to be 0.2. That's the square root of 0.04 or 4%. Now, we take that 0.2 and we put it down into this formula here. And so 1 plus 0.2 is 0.12. 1 minus 0.2 is 0.8. And if we divide that out, we're going to have 1.5. That's our SWR for 4%. These lines here around the Gamble symbol it means that it's an absolute value. An absolute value is on a number line, it's a distance from 0. So if this was a -3 or a 3, it would be the same thing. It's 3 digits away from 0. That's all this absolute sign means here. Now, knowing that we have a SWR of 1.5, we can determine what our reflected power is. So we take the SWR minus 1 divided by the SWR plus 1. So it comes out to 2.5 divided into 0.5, and that's 0.2. Of course, we have to square that. So 0.2 times 0.2 is 0.04, or 4%. Now, I made up a little unit here to test the transmitted and reflective voltage coming back on the oscilloscope. And I had a little diagram here that I used. I don't know who to give credit for this. I don't know if it was an MFJ one or not, but I didn't do any of this stuff. I just did the coil and a couple resistors and some diodes. And these resistors over here, I didn't use the same values, and I didn't match the pairs up. So we'll see how it works. I put it on the oscilloscope to test the transmitted and the reflective voltage, and we'll see what it looks like. We'll go over there now. The top trace is the forward voltage, and the bottom trace is the reverse voltage. You can see that they're out of phase with each other. I'll show what it looks like on my SWR meter. You read the SWR where the two needles cross. In this case, it's going to be a 3.